Hello, everyone. Thank you for joining me in this session and welcome. This session is going to be really exciting as we're going to discuss about modern applications and how developer tools becoming more important whenever it comes to building applications. We use tools when we write our codes, when we write our unit and integration testings, when we package our application into container, and the list goes on and on. And the more you adopt modern development approach, like building event-driven architecture in your microservices, the more you realize that you also need to implement best practices in DevOps. And two areas in DevOps that widely adopted are building release pipelines and infrastructure as code. And we definitely use tools to implement these two practices. And that is what we're going to talk about in this session. In this session, we're going to talk about how that we can use modern tools to build modern application. This session is perfect for beginner or even intermediate users, and I designed this session for those of you who are just starting out on a journey with containers and looking for a solution how to run containers on AWS with help of available development tools. Quick introduction of myself. My name is Donnie Prakoso. I'm an AWS Senior Developer Advocate covering for ASEAN. For the past 17 years, I've been building services and solutions for various industries ranging from banking, telco to startups. Especially for startups, before I joined AWS, I was a technical advisor for several startups in various verticals, such as media entertainment, e-commerce, digital agency, and machine learning-based startups. Most of them were based in Indonesia, and few of them were based in Europe. My specialization is microservices, event-driven architecture, and all sorts related to containers and serverless. So if at some point you have questions related to those fields, feel free to reach out to me on LinkedIn and Twitter. So in this session, we have lots of things to share with you, especially for the demos. We're going to build an API, and we can test the API using curl command. And a sample demo is like what you see on the screen. And we're going to deploy the app using Amazon ECS and AWS Fargate with the latest development tools, and that is AWS Copilot. But we will not stop there. We are also going to integrate the application with database like Amazon DynamoDB to show you how to integrate your apps easily with other AWS services. And also, modern application is not complete with CI/CD. And we're going to walk through on how that you can build a simple but powerful release pipeline with AWS services and using a single tool, and that is AWS Copilot. And lastly, I will show you how that you can extend your system by integrating AWS Copilot with AWS CDK. So it allows us to create additional resources and integrate with other services. These are the key takeaways of this session. And after this session, we will understand how modern development tools now extends its functionality to integration with cloud computing to provision the resources for our application. I will also share with all of you two tools that you can mainly use to build modern application on AWS, and they are AWS Copilot and AWS CDK. Now, to give you a better understanding on how to use these tools to build application, I'll be going back and forth between demo and slides to give you a big picture on how that you can deploy applications with AWS Copilot, define new service, implement infrastructure as code, checking the logs, and building multiple environments to implementing release pipelines with CI/CD using AWS Copilot. And I will also show you how to extend the system built with AWS Copilot using AWS CDK. So we're going to use the add-ons resources that allows us to extend the system with help of AWS CloudFormation template. And this is the agenda for today. We will start by setting the context on why and how tools becoming an integral part of our development. And in this segment, I will also explain how our decisions to adopt modern application development approach, like building the apps with microservices architecture, using DevOps principles, extends the functionality of tools. Tools are not only for programming, but also to integrate with cloud computing. So in this session, I will talk more on building apps with containers, and this is a good opportunity to introduce you to a few of container services on AWS, and that is Amazon ECS and AWS Fargate, and how you can easily get started by using AWS Copilot to bootstrap and deploy your application, as well as operating your apps. I will use the remaining of time to do demos, and I will take you through a step-by-step demos so you know how to deploy a container from your local development into a production-ready environment. Lastly, I will be closing the session with some resources that you can use if you want to dive deeper into modern developer tools, AWS services, and free hands-on tutorials. Lots of exciting stuff today, so let's get started. First, let's talk about how developers use tools to build applications. And one of the reasons why we as developers love to use tools simply because tools can have a massive impact on helping to get our works done. And if the tools that we are using not adequate enough to help us do our work, we can simply become frustrated, as that means we need to figure out by ourselves to get our development work done. And that means we will lose more time compared to using proper tools. So in contrast, if we use the right tools to do our work, we can build better apps as we can focus more on how to improve the application rather than manually doing repetitive and mundane tasks, which should be handled by the tools. And that also means that we can go to market faster by providing more value to our customers. So in the end, we find happiness if we get the job done. And our customers are also happy as they can use application as what they expected in timely manner. And I've been thinking about that hypothesis that developers require tools to improve their development workflow. I've been thinking about that for years. So when I came across and read GitLab Global Developer Report in 2016, I found that 81% of developers say that for them, it's critical for organizations to use the latest development tools. In the report, one of the key findings is developers are tired of outdated systems and crave modern tools. And this also means that they are moving forward to modern development approach. Either they are using serverless or containers or even both. Another interesting finding was CI/CD is integral to everyday work. They work on their codes, commit to Git repository, and letting everything runs to their application environments by relying on CI/CD process. And this means that developers also use CI/CD tools to implement DevOps principles in their journey. And the last thing that I like to emphasize from this report was also say that learning curve is the biggest challenge when it comes to adopting Git. Well, I will not say it's only for Git, but for most of modern technologies out there. We are living in a rapid pace of technology's advancement. There are new services that might be beneficial for our applications, but the problem is that we need to learn about that particular services or technologies, and we'd like to avoid spending a long time to learn before figuring out whether the service is feasible for us to use or not. And this is where tools can help us, especially those tools that already integrated with best practices, which will significantly help us to cut the learning curve. And at this stage, you're probably wondering, since when we need to use modern tools? Or what are the factors that trigger us to use more tools? So I want to go down to the history of application development, and I will briefly cover this just for you to understand the major factors. So ever since the rise of cloud computing, it unlocks the possibilities for almost all organizations to expand their businesses to meet larger scale of demands. It removes the need to do capacity planning and procure the service to be the main infrastructure for our applications and supporting services. With cloud computing, we can provision computing resources in an instance, scale up and down based on the demand, use the managed services that range from database to machine learning, and also use the latest technologies such as serverless, containers to blockchain. It opens the opportunities for developers, for us, to innovate. And as the technology grows and we adopt those technologies, we progressively transform the way we architect our application. We move from monolith to microservices architecture, as that is one of the options for us to grow, both from business and technical aspects. As we move to microservices, it means that we have more of application that we need to deploy. We switch from traditional approach from using VMs to use containers. And using containers provides us lots of advantages, such as predictable deployment, portability to improve performance compared to traditional approach. Using containers to ship our application in microservices architecture also means that we need to improve the way we build release pipeline and provision all the resources. And we are slowly moving to adopt DevOps development approach. With numbers of requirements to properly build microservices, we simply cannot do all things manually. We need tools. These tools are the practical implementation of using DevOps as our main practice. We start to build CI/CD and ISC, or infrastructure as code. We now use tools to automate application delivery with CI/CD. We use tools to provision resources required for our application using microservice architecture. And we use these tools to reduce the errors that probably could happen if we do it manually. We keep on improving. Now we have established how modern development tools are the integral part of our workflow and how containers becoming the preferred approach for developers to ship their application. And still in the container space, when it comes to managing all of containers to host our application, we need to choose the most suitable container orchestrators. Choosing the right container orchestrator is a key integration point as it will deeply influence your future development. One of the container orchestrator that is widely adopted by developers is Amazon ECS. Amazon ECS has a set of rich features from networking, integration to VPC, and scheduling strategies that places containers in your cluster based on the requirements. And what Amazon ECS is really excel at is the simplicity it provides. With Amazon ECS, it reduces the time it takes for you to build, deploy, or migrate your containers application. And it also comes with AWS opinionated solution for running containers at scale. And this also translates to various best practices of running containers already baked inside Amazon ECS. ECS provides you a managed control plane to run containers. Now, the next thing that we need to understand is which computing options, nodes, the resource pool that we are going to use to host our application. And it is at this point that AWS Fargate has an important role to play. AWS Fargate is a technology you can use with Amazon ECS to run containers without having to manage Amazon EC2 service or cluster. With AWS Fargate, you no longer have to provision, configure, or scale virtual machine clusters to run containers. And this eliminates the need to choose a server type, decide when to scale your cluster, or optimize cluster packing. Now, to simply put, AWS Fargate is a serverless container and fully managed data plane that you can use to run your application. And as I mentioned, you can use AWS Fargate with Amazon ECS. Now, the next question is, why using Fargate matters to you, matters for us developers? Simply because with Fargate, it can provide a significant operational saving. Why? Because with Fargate, it frees you from having to manage any of the underlying infrastructure, and it also comes with improved security. And Fargate is running on serverless, so you can focus building on your product and not the infrastructure. The diagram on the screen shows us the typical process to ship application. Two main services that are most commonly used by developers to run their containerized application on AWS is Amazon ECS and AWS Fargate. By integrating these two technologies, you will gain more benefits for staying agile and still have scalable and highly available system. Running a single container is easy, but in reality, we often need to deploy more than one container. It could be tens, hundreds, or thousands that we need to deploy. And this is very relevant to the current conditions where, in general, organizations and developers are moving to adopt microservices consisting of a variety of services. So now we're going to focus on simplicity, but still giving you the rich features and powerful ability of Amazon ECS. And we're going to integrate with AWS Fargate, serverless containers, so you can have more time building your apps and not managing your infrastructure. The next question is how? How we can easily ship out containerized application to Amazon ECS with integration of AWS Fargate. And that is where AWS Copilot comes into the picture. AWS Copilot is a CLI tool that will greatly help you to get started with containers. Not only is the best tool for you to get started, but also gives you the flexibility to extend your system. So, in case that you are now starting with a simple application or you want to extend your architecture into microservices, AWS Copilot has it all for you. If you're just getting started, you probably has all of these questions. How do I deploy my application? How do I extend the system? How do I integrate with CI/CD? And the list goes on. And if you're building microservices and looking for advanced use cases, you probably wondering, how do I build PubSub for asynchronous communication? Or even, how do I create multiple environments and still maintaining the dev or production parity? And that is why AWS built Copilot, a single tool to address these three challenges around developing containerized application to simplify building, releasing, and operating apps. So as mentioned, AWS Copilot is a command line interface or CLI that you can interact in your terminal, which enables you to quickly launch and easily manage containerized application on AWS. AWS Copilot provides a simple declarative set of commands, including examples and guided experiences built in to help you to deploy your apps quickly. So when it comes to deploying and operating your applications with Copilot, Copilot automates each step in the deployment life cycle, including pushing to a container registry, creating a task definition, creating a cluster, down into the details of the operational logistic. And one of the advantages of using Copilot is that all AWS best practices are embedded into this tool, so you can have scalable, reliable, and extensible application with less effort. And when I say Copilot is here to simplify the build, release, and operation of containerized application, it is really easy and simplified. If I want to deploy the application, I only need to run Copilot service deploy. It will deploy the application to the environment that I have configured with Copilot. If I want to add storage like Amazon DynamoDB, Aurora Serverless, or even object storage like Amazon S3, all I need to do is to run Copilot storage in it. And if I need to create an environment, like in my case, staging and production, all I need to run is Copilot env init. With the default configuration, it will create a VPC for us with 2 public subnets and 2 private subnets. And the beauty of this is that I don't need to configure them manually one by one. And that's helping me to avoid any conflicts between one environment to another environment. And lastly, I can also define the release pipeline with Copilot. And this way, I can deploy my application that I've built, configure with Copilot, and deploy into staging and production automatically. I love this. This is exactly what I need. So let's see AWS Copilot in action. And in the next demo, we're going to deploy the application and into Amazon ECS and AWS Fargate. And just a quick overview on what kind of application that we're going to deploy today. The applications that we are going to deploy is simple application to return HTML based on the markdown text that we pass as input. So the application will convert the markdown text into HTML using HTTP post method. We're going to use AWS Copilot to deploy our application. And at the end, we're going to have an application load balancer with a public address, which will be connected through AWS Fargate service, where our application run inside the Amazon ECS cluster. Let's jump into the demo. In this demo, we'd like to show you the capabilities of AWS Copilot to deploy your application. Just a quick overview on what kind of application that we're going to deploy today. The application that we are going to deploy is a simple application to return HTML based on the markdown text that we pass as input. So the application will convert the markdown text into HTML using HTTP post method, and we can use the output. This is the source code of the application. The application itself is written in Python and using Flask framework. For the same endpoint, which is root, I've defined different processes for get and post method. For every request to get method, it's going to simply return OK. And this endpoint with get method is mainly used for health check by ALB. The other method, which is post, is going to process the markdown text and return the HTML response. I also have a Docker file that is going to be used to deploy the application. This Docker file uses Python 3 as the base image and is going to install the requirements, running on port 9090 and run the application. At this stage, I already have a test environment properly configured by AWS Copilot. If you are wondering how to build environments with Copilot, I will show you in the next demo. But for now, we already have the test environment. Then, all I need to do to deploy the application is by running command Copilot service deploy, along with the service and the environment name. And once it's finished, we will get the endpoint. Cool. Now, let's test it out. I'm going to test the endpoint using curl command. With this curl command, I'm sending a request with post method along with the input using text as the variable name. The value of the text input is a text in a markdown format. And we get the results. As you can see in this demo, Copilot makes it easy to deploy application into ECS and AWS FileKit. As you develop your applications, you will certainly add new features. And most of the times, new features also requires integration with specific AWS services. For example, how if the Markdown Service API needs to integrate with Amazon DynamoDB to log all the requests converted from Markdown to HTML. So, how can we do that? There are two ways on doing this. If you need to integrate with services that already integrated with Copilot, such as Amazon S3, DynamoDB, or Aura Serverless, you can use Copilot storage command. How about other services? You can easily integrate more AWS services with your application by adding a CloudFormation template into respective add-ons folders. Copilot will pick that up and provision the resources as well as integrating the IAM role. Wondering how all of this works? Let's jump into the demo. Okay, so now we have our API app deployed, but it needs a database so we could log all the requests. Let me guide you for a quick walkthrough for the source code. This is the app.py file, the main file for the API application. I have added a new function which is called as save data. This function will save the request this application received into a DynamoDB table. And if we go to the main function, you see that I have added a line to call the save data function. Our code already integrates nicely with DynamoDB, and what we need is the DynamoDB itself. So let's run Copilot storage init. Once we run this command, it will ask us a couple of questions, like storage type, and in this case, we choose DynamoDB. Then the resource name, partition key, and others. So let's finish this process. Okay, so once it's done, we will have the manifest created. And you can also see the environment variable name for the DynamoDB table that we can use in our code to define the object for DynamoDB table name via the environment variable. So let's change the table name by using the value from environment variable. Okay, so now the application should connect to the DynamoDB properly. Next, manifest file. To find the manifest file, you can browse to the add-on folder. As mentioned, if you need to integrate your applications with other AWS services, you can create AWS CloudFormation template in this folder. So let's take a look into the manifest file. This is how manifest files looks like. It's a CloudFormation template, and in this case, it defines Amazon DynamoDB for our application. If we scroll down to the end of the file, you see there are two outputs, and one of them is the IAM role. And this is important, and I hope you don't miss this part. Because with this IAM output, it will help Copilot to inject the IAM role into your application so it has sufficient permissions. All right, at this stage, we don't need to change anything. So let's deploy this DynamoDB integration. To deploy the application, I just need to run Copilot service deploy and add the service name. This will take a while, so let's wait until it's finished. Alright, seems the deployment is finished and we have all required resources from DynamoDB to the IAM role attached to our application. Okay, so there's no issue, which is good. Now I want to check if the DynamoDB table is created. So let's go to the console. This is the DynamoDB console. And if I filter by the name, I can see there's one table created. Now, if we run the API again, passing the markdown tags, it now will log the data into the DynamoDB, and we will also have the HTML response as well. So now let's go to the DynamoDB console to see if the last request is logged properly. Okay, so our application now integrates nicely with DynamoDB, and we can see the last request is in the database. And that is how you integrate your application with other AWS services using Copilot. In the previous demo, we have learned on how that we can use AWS Copilot to deploy our application. Now, when it comes to modern application, one of the best practice is to implement CI/CD as early as you can. And CI/CD gives you benefit in the long run, as it will increase your development velocity. So in the next demo, we're going to build a release pipeline. So whenever we push our changes into our Git repository, it will automatically build the image, push the container image repository, and deploy to specific environment in Amazon ECS and AWS Fargate. It's not as hard as it seems. In fact, with Copilot, it's simple and straightforward. So let's jump into the next demo to implement CI/CD with AWS Copilot. In this demo, we're going to create a release pipeline for a single environment. We're going to use the demo that I used in the previous demo. Before we're going to create the release pipeline with AWS Copilot, I'd like to show you how to create an environment with AWS Copilot. To create an environment, you can use Copilot env init command. Copilot env init creates a new environment where your services will live. Copilot will guide you throughout the process and ask you a couple of questions, such as the environment name. In this case, I name it as test. And also the name profile to specify which AWS account and region I like to have our application runs in the environment. I will use my default profile for this demo and just let it finishes the process. You can also use various flags provided by AWS Copilot to create environment. For example, you can also import existing resources like VPC and subnets to your preference. Now, as we have an environment for our apps called test, the next thing that we need to do is to deploy our application in test environment. To deploy our application, we can use Copilot service deploy command. Now our application is deployed. Let's check the application by running Copilot service show. Again, if you didn't specify the information with flags, it will guide you throughout the process. And this is something that I really like as it's quite intuitive. You will see that we have our application now running in test environment. Once that we have the environment built, we now can check the status of the environment using Copilot env show command. This command shows information about particular environment. Some of the information includes the region and account of the environment, the production info if the environment contains production services, and also the services running in the environment. Let's try to test it out. This is a simple application that's going to convert a markdown text to HTML. And if we do a simple curl command using post method along with the text variable, we're going to get the response in HTML. This is good, since this means our application is running properly in test environment. Next, let's try to create the release pipeline with AWS Copilot. To create a release pipeline, all we need is to do 3 commands. First, Copilot pipeline init. The second step is you need to commit and push all changes to your Git repository. And the third step is to update the pipeline configuration by running Copilot pipeline update command. So let's do them one by one. Let's run Copilot pipeline init. This command will not create your pipeline yet, but it will create manifest file that will be used to create your pipeline. You can find those manifest files inside the Copilot directory. There are two new files generated by Copilot. They are build spec and pipeline YAML configs. Let's go through each of them. Build spec file contains the instruction for building and publishing your service. For most cases, you can leave the build spec file as it is. But for some cases, you might want to run additional command and you can add them to the build spec config. As for the pipeline file, this file contains instruction on how code pipeline needs to retrieve the source file, which environments you want the pipeline to deploy to. Let's commit and push the files. Then we can instruct Copilot to integrate this pipeline with Copilot pipeline update, which will let Copilot to integrate with AWS Code Pipeline and also AWS Code Build. And in this stage, if you're using an external Git provider like GitHub, Copilot needs to create the connection, and we need to update the pending connection as a way to approve it to make available for use. So let's wait. We can also check the end result of our pipeline in the Code Pipeline console. This is the visual representation of our pipeline. You can see that we have three steps here: source, build, and deploy. So let's get back to our terminal and make some changes to our application to see if the pipeline works as expected. What I'm going to do now is to add environment variables into the application and retrieve it from the app. To do that, I need to open the service manifest file. Add the environment variables for test environment. I'm going to name it as running env, and with value this app is running on test environment. And open our application file and add the environment variables as the part of the response. And that's it. Now what I need to do next is to git push my changes. Now we can see the status of our pipeline with Copilot, and it's currently running. Let's wait until it finishes processing. And our app is deployed successfully. Let's test it out. To test this app, let's find the URL of the application by calling Copilot service show. And we also see that we have the environment variable from the test environment. Let's try to test it out. And yes, we can see that we got response from the application. We got the HTML response from the Markdown input, and that means our app works. And we also see that we have the environment variable from the test environment. Okay, so now we know how to create a release pipeline with AWS Copilot. But in practice, we have more than one environment. It can be staging, testing, UAT, and production. You probably use staging to integrate all the services that you built and do a series of testing just to make sure everything works properly. And once it's done, you deploy them into production environment. So let's jump into another demo on how that we can easily create another environments and also creating release pipeline for multiple environments with AWS Copilot. In the previous demo, we have our application deployed to test environment. Now we are going to add another environment which is called prod and set up the pipeline to deploy to the prod environment. To do that, we need to create the prod environment. We simply call Copilot env init again, and this time we will name it as prod. Alright, now we have the prod environment set up. Next, we need to open the pipeline YAML and add the prod stage. Now to add the prod stage, we simply add a new line and name it as prod. That's it. Very simple, isn't it? This way, we instruct Copilot to create the pipeline and also for the prod environment. Now, one thing that you need to remember is Copilot will do deployment in the order of the stages that you have defined here. In this case, we have the test environment first to be deployed, and later on it will be deployed to prod.
Whenever you make changes to pipeline, you need to update it again using Copilot Pipeline Update. Let's wait until Copilot finishes the process. Now we see that Copilot already finished the process, and we can see the deployments to test and prod our success. We now can test out the application in prod environment. So let's get the endpoint. Now let's do the curl test. You can see that our application runs properly. If we execute Copilot app show, we will see that we now have two environments for our application. And this is one example of continuous deployment. But in practice, we don't want to deploy automatically to the production environment. And with Copilot, we also can enable the manual approval step before the deployment. To do that, we need to go to the pipeline YAML. Then we go to the prod stage and add requires approval properties. This will instruct Copilot to pause and wait for approval before deploying to production. Now let's update the pipeline. And let's wait. We can see that the deployment to test environments is finished. So let's go to the code pipeline console. When code pipeline finishes the deployment to test environment, the pipeline stops and not reach the prod environment yet. We now need to manually approve it to deploy to production. So let's click this button. And this feature is super useful in practice because most of the cases, we need to ensure that everything works fine. We need to do UAT first before it goes to production. We need to have somebody to review it first before it deploys to production environment. And this is the implementation of continuous delivery as we have a manual approval before it goes to production. And that is how you build pipeline with multiple environments with Copilot.
At this stage, you have a good understanding the set of capabilities on how AWS Copilot can help you building your applications. We have seen how we can initialize application, deploy services, integrating with database, as well as implementing CI/CD, all with a single tool using AWS Copilot. And as mentioned, the more you develop your applications with cloud computing, eventually you will have the need to integrate with fully managed services provided by cloud computing provider, in this case AWS. So the next question is, how do we integrate our applications with other services? Fortunately, you can still do this with AWS Copilot. Copilot has the feature called add-ons that allows us to add additional AWS resources by leveraging CloudFormation templates. And these resources can be anything from databases using Amazon RDS, Elastic File System using Amazon EFS that helps you to automatically grow and shrink as you add and remove files without the need for management or provisioning. And the way these add-ons works is pretty easy. The first thing that you need to know is that you can create additional resources by leveraging CloudFormation templates. The next thing you need to do is by creating an add-ons folder within the service folder that you already have. Then you just need to put the CloudFormation templates, defining all the resources that you want to associate with your service into this particular folder. So what happens next is the next time Copilot deploys your application, it will merge all these files into a single AWS CloudFormation template. Now we know that the most crucial part in this step is to define the CloudFormation template. You probably has a question, how can I get started easily with defining the resources in the CloudFormation template? There are two ways on doing this. First, you can look into the AWS CloudFormation template documentation and create the template based on the information. Or you can use tools to help you to do that. For this session, let's stick with the tools since it helps us to get things done easier and quicker. And this is a good transition for me to share with you another tool, and that is AWS CDK. The AWS Cloud Development Kit, or AWS CDK, is an open source software development framework to model and provision your cloud application resources using familiar programming languages. You can do this in different programming languages such as Python, JavaScript, TypeScript, Java, or C#.
With CDK, you will be much faster than with previous tools because you work with your familiar language and concepts, classes, and method without context switching. You also have all the tool support from the programming language, such as autocomplete, inline documentation, tests, linting, debugger, and others. And the most important part is that you're able to build your abstractions and components of the infrastructure and application. One of the most important concepts in AWS CDK that will definitely help us to get things done easier and faster is construct. Constructs are the basic building blocks of AWS CDK apps. A construct represents a cloud component and encapsulates everything AWS CloudFormation needs to create the component. A construct can represent a single AWS resource, such as Amazon S3 bucket, or it can be a higher level abstractions consisting of multiple AWS related resources. So the constructs are organized in three different levels. The L1 are constructs that are automatically generated from the CloudFormation resources specification. This is the one by one mappings between classes and AWS resources. L2 are the higher level service construct to represent resources such as Amazon S3 bucket or a VPC, including other resources. So this can be a composition of multiple resources but still tied to one service. These constructs are simpler and requires a very little input to generate complex CloudFormation templates, and they can have many defaults and opinions. L3 plus are opinionated abstractions that are created by AWS. For example, creating ECS service with ALB and VPC. This is the level where you will create your own abstractions that can be reused. So looking back to AWS Copilot and AWS CDK, here's how you can integrate between these two tools. The first thing that you need to do is to create your stacks and construct with AWS CDK. Essentially, create all the resources that you need with AWS CDK. Once you have your CDK application, the next thing you need to do is to create the CloudFormation template. And to do this, you can just simply run CDK synth and it will create a CloudFormation template. Now, to add CloudFormation template as one of the compatible templates for Copilot add-ons, we need to make some adjustments. And what we need to do is to replace the parameters with the template from Copilot, and that is including application name, environment name, and service name as parameters. Then, as the resources, you can replace what with CDK has generated for you. Now, once that you have the template, the next step is, as you probably have guessed it, you can put that template into add-ons folder in your Copilot service folder and run Copilot deploy. It will then create the resources for you. In the next demo, to demonstrate how to integrate AWS CDK and AWS Copilot by creating add-ons, we're going to build a new service called text, which need to evaluate the text input provided by the client and predict the language of the input, as well as extracting key entities found on the input. And that includes organizations, date, event locations, commercial items, and others. And as you might guess it, this is a task of machine learning, and we're going to integrate the service with Amazon Comprehend. Amazon Comprehend is a natural language processing or NLP service that uses machine learning to uncover valuable insights and connections in text. And this will make our task a lot easier as we don't need to build our own machine learning model, and we can just call the API provided by Amazon Comprehend. But there's another thing that we need to do. As AWS is secure by default, we need to add permissions through IAM for our application to call Amazon Comprehend. And this is where CDK plays a role in our process. Let's jump into the demo to show you the integration between AWS CDK to create the IAM and AWS Copilot. In this demo, we're going to integrate our application with Amazon Comprehend. We're going to do that by adding a new service called Tag Service. This is the source code of the tag service. As you can see, this application received the input from post method and getting the JSON payload. Then it tries to detect the dominant language provided by Amazon Comprehend API. If the text is in English, it proceeds by calling another API to extract entities in the text. Then we will return the results. Now, as mentioned,
If we just proceed by deploying the application without setting up the IAM policy, we're going to get the permission issue. Simply put, because our application it doesn't have any required permissions to call Amazon Comprehend API. So in this case, I have deployed the service. And if we follow the logs by running the Copilot service logs with follow flag, we can see the latest log from the application. And if I open a new pane and run the curl command to simulate the request with the payload, we will see we have internal server error from the status code. Now, if we see the logs, we can see that there's definitely a permission issue. So what we need to do now is to add the permission. So let's open our CDK application. The goal of building the CDK application is to create a policy which has sufficient permissions for our text service to call Amazon Comprehend APIs. I'm implementing least privilege, so I just need to allow the policy to have specific actions. In this case, it's performing two API calls, detect dominant language and detect entities. Then, if you're creating add-ons template for Copilot, one of the most important steps is don't forget to output the ARN of the resources. In this case, is the manage policy ARN. Okay, so everything seems properly configured. Next thing that I need to do is to get the CloudFormation template generated by AWS CDK. To do this, I can run CDK synth command and piping the output to a specific file. Then we need to edit the file so it's compatible with AWS Copilot add-ons. First thing is that we need to find the parameter section and remove everything. The reason is because we are going to add Copilot add-ons parameters. And they are app, which is the application name, env, and this is the environment name, and the last one is the service name. Once we have made the edit, we can simply move this file into the add-ons folder within the Copilot. What I need to do now is to create the add-ons folder first, as it's not created by default. Then I move this file into the Copilot add-ons folder that we have just created. Then if we go to the Copilot service folder, this is how the text service files looks like. Alright, we have done all the hard parts. Let's deploy the text service. Okay, so now it's already been deployed. Let's check if the application is working as expected. First, we need to get the URL so we can test it out. We can do that by running Copilot service show. Now I'm going to send a curl request to the text service. The input text that I use was the sample text when you log in into Amazon Comprehend console. And if I run this command, you can see that now the application works. And that means we have now integrated the AWS CDK as a tool to create IAC and use the add-ons folder within Copilot. So we can create and integrate additional resources with AWS Copilot applications. If you want to know more about how to develop containerized application with AWS Copilot, you can visit copilot.rocks. Copilot.rocks is a site where I document all my learnings and solutions to work with AWS Copilot in form of tutorials, complete with working source code. And this will definitely help you to get started easily and grow your applications into microservices by implementing PubSub or other solutions provided here for various use cases. And also, you can visit my YouTube channel as I produce more video content on how to get started with AWS services. This channel is more to help you get started and perfect for beginners who just starting out their journey on developing with AWS. So that's all for today's session. Thank you so much for your time. Hopefully, the content and demos presented in these sessions help you to understand how you can build modern applications with modern tools using AWS Copilot and AWS CDK. And more importantly, for you to enjoy more and having fun building apps with AWS. If you have any questions, feel free to reach out to me on Twitter or LinkedIn. Once again, Thank you so much. I'm Donnie Prakoso and happy building.